In this lesson, you will learn how to prevent crucial private data, such as bank account routing numbers and credit card numbers, from leaving your network and being inappropriately transmitted. Data leak prevention, DLP, is required by some compliance regimes, such as PCI, DSS, and HIPAA, but other networks may also find it useful to help prevent student cheating, for example. In this lesson, we will explore the following topics: data leak prevention, DLP, DLP filters, DLP fingerprinting, DLP archiving, best practices. After completing this section, you should be able to explain DLP's role in the network and understand the basic theory of how it works. By demonstrating competence in knowing what DLP offers and when to use it, you will be able to decide the most appropriate ways to implement DLP in your network. FortiGate has other features, such as IPS and antivirus, that can detect and block files. What makes DLP different? Why should you use it? Traditional firewalls and first-generation UTMs were designed to prevent attacks and nuisances from getting into your network. Web filtering is applied only to incoming traffic. Although it is the best practice to apply it in both directions, many people apply antivirus and email filtering only to incoming traffic. DLP prevents specific data from getting out. How can traffic that is leaving your network affect security? Coworkers often share sensitive documents inside your network. Sensitive information is also shared between servers that work together to host a single application. But if sensitive data, such as financial information, becomes public, it can have serious effects. Stock prices, bank transactions, privacy, and password security can all be compromised. DLP helps to ensure that your network follows the rules required by your real-world organization and doesn't give out important information. So how does DLP work? FortiGate scans traffic matching to your firewall policy, looking for the DLP patterns that you specify. When you configure a pattern, whether predefined or custom, DLP doesn't directly inspect traffic. Instead, it communicates the pattern to the proxy or IPS engine's processes, which do the scanning. So when you're troubleshooting, you may need to investigate traffic flow through modules that you didn't manually enable. If the scan finds a match, it executes the filter's corresponding action. In the example shown on this slide, the first two filters didn't match the file, but the third one did, so FortiGate performed its action. Good job! You now understand the basics of DLP. Next, you'll learn about DLP filters. After completing this section, you should be able to differentiate filter types for files from filter types for messages, configure DLP filters for files and for messages. By demonstrating competence in knowing when to use DLP and how to configure DLP filters, you will be able to enforce DLP in your network. Now that you've had an overview of DLP, it's time to look at some specifics, such as how to add filters to a DLP sensor. Initially, you'll use some default file filters and message patterns. Later, you'll learn how to customize and expand those file filters. Most DLP behavior is dependent on the filter type. You will learn more about filter types later in this lesson. Right now, let's look at service inspection and action. First, you need to modify the GUI menu settings to show DLP. It's hidden by default. You do this on the Feature Visibility page, then go to the DLP submenu available under Security Profiles to create a DLP sensor. Inside it, add a filter. In each filter, you'll specify match criteria, which protocols to scan, actions that FortiGate applies when traffic matches. Note, DLP is available only in proxy mode virtual domains, VDOMs. In the Examine the Following Services section, choose which network protocol should be scanned. Like other security features, secure protocols aren't in the list of network services that can be scanned. However, if you enable SSL SSH inspection, specifically deep inspection, FortiGate will scan each protocol that you choose and its secure equivalent. For example, if you select the checkbox for HTTP, FortiGate will scan HTTP as well as HTTPS. More information about deep inspection is available in the Certificate Operations lesson. Note, FortiOS carrier models also examine MMS services, MM1, MM3, MM4, and MM7. For each filter in the DLP sensor, you must select an action. What FortiGate does if traffic matches. The default setting is log only. If you're not sure which action to choose, the default setting can be useful initially. While you study your network, use this action to see what sensitive information is being transmitted. Later, you can fine-tune your sensor and select the most appropriate action to block sensitive files from the WAN. Now, let's return to the top of the filter, which is the more complex part of the configuration. Select the filter type, either Messages or Files. Most other available options depend on this initial choice. Messages scans for words, credit card numbers, or other text-based patterns directly embedded in the protocol, not as a file. There are two pre-configured message filters available, credit card and SSN. If the predefined DLP patterns don't match exactly what you're looking for, you can use the regular expression option to configure your own custom pattern. Use PCRE syntax. Supported expressions and performance with complex expressions always vary by the regular expression engine. So if you're looking for references, look specifically for PCRE, not others, such as the similarly named Perl language. File changes the available options to be appropriate for files, such as file size, fingerprinting, and watermarking. In the example shown on this slide, a pre-configured message filter blocks credit card numbers from leaving the network. The block action stops the violation traffic, but it also generates a log, which you can view in the forward traffic logs. The logs provide information such as security event, result, and firewall policy. Select the log for more details. The Details tab provides more information about source, destination, action, and more. The Security tab provides additional information such as the filter type, filter category, and DLP filter index. Let's take a look at the file-specific subfilters. File name patterns are intuitive. If a file name is an exact match or matches the specified pattern, then FortiGate performs the specified action. If an important file name can have variations, users often try to evade DLP by renaming files to a harmless-sounding name, then you should use patterns for matching rather than the exact file name. Configure FortiGate to match all intended file names, but no unintended file names. For example, browsers often rename downloads or duplicate file names to prevent accidentally overwriting an existing different, yet identically named file. For example, they would add "to" before the file extension. Likewise, Windows renames copies of files so that they start with "copy of." So you should use a name pattern such as nice*.jpg, not the exact file name, nicepainting.jpg. The example on this slide shows which filters would match the file name and which filters wouldn't. But what if the file name doesn't match any pattern? What if the file name is radically different, and therefore a broad pattern would cause false positives? For example, what if we want to block all executables regardless of name or platform? File name matching alone is often not enough for very sensitive data. You may want a more sophisticated filter. One alternative is to use file type matching. File type matching behaves as you'd expect. FortiGate does not identify file types by their extension. For example, .doc. This is because users could circumvent DLP simply by renaming the extension. Instead, FortiGate identifies file types by scanning for matching binary patterns. That is, how the file type stores data in specific areas, in specific patterns of ones and zeros. However, in order to use this accurate technology, FortiGate must have a corresponding decoder that understands the binary data source. Without a decoder, FortiGate cannot decipher the string of ones and zeros, and therefore cannot identify the file type. If you select the Files option as the filter type, and select the Specify File Type option, the file types and file name patterns fields become available. The File Types list contains a predefined list of file types that you can select from. The File Name Patterns is a field in which you must create and enter custom patterns that you want to apply. Initially, this list will be empty. You enter the desired pattern in the Search Text field and click the green plus button to add it to the list. After you add it to the list, you can select that pattern to add it to the filter. After you add it to the list of patterns, it will remain there for future use and can be searched using the Search field. When you make a selection in the File Types drop-down list, DLP scans file contents of the file type that you select, regardless of the file name or extension. Even if the file is renamed with a different extension, DLP will detect it. After you type a value in the File Name Patterns field, DLP scans the names of files looking for patterns that match the values you specified. Good job! You now understand DLP filters. Next, you'll learn about DLP fingerprinting. After completing this section, you should be able to implement DLP fingerprinting. This includes knowing how to monitor specific data types and how to configure DLP sensors. By demonstrating competence in knowing when to use and how to configure DLP fingerprinting, you will be able to better control the types of files that are allowed to leave your network. When scanning files, using file types and file names aren't the only options that you can use. On most networks, it's usually not an option to block all Microsoft Office files, and blocking by file name is not effective if users try to circumvent. So what alternatives do you have? FortiGate can use a content-based filter called document fingerprinting. Document fingerprinting identifies specific files using one or more cyclical redundancy check (CRC) checksums. You can apply this content-based filter to many files at once, including large files. How accurate is document fingerprinting? How many checksums will DLP calculate and store? The file itself is not stored in FortiGate, only the checksums of chunks. Smaller chunks mean that more checksums will be calculated for each file, and DLP will fingerprint more accurately. That is, even if someone changes a file in a few places, fingerprinting will still be able to identify it because the checksums of the other chunks will still match. The trade-off is that more checksums require more storage space on FortiGate, so you must decide the best balance between performance and accuracy. Note, the document fingerprint feature requires a FortiGate with internal storage. Before you configure any fingerprint filters in a DLP sensor, consider whether you'd like to make custom sensitivity level tags. For example, you can make a custom sensitivity level named Finance. When configuring fingerprint filters, you can use the Finance sensitivity level to tag all money-related fingerprints. The sensitivity level has two effects. It appears in log files. When you configure each filter in a DLP sensor, you will select which fingerprints the file filter will use by specifying a sensitivity level. All fingerprints that have that sensitivity level will be included in that filter. After you've defined custom sensitivity levels, you're ready to define your fingerprints for network share documents. Using the CLI, you can configure FortiGate to connect to a file share on a daily, weekly, or monthly basis. Each time it connects, FortiGate can automatically recreate checksums for all files in the share, or retain old fingerprints in case an old version of the file is still circulating. Fingerprinting through a file share allows you to add many files and update the fingerprint for each addition or change. While configuring, choose which sensitivity level FortiGate will use to tag those fingerprints. After fingerprint sensitivity and the network share are configured, the next step is to configure the DLP Sensor's filter. The fingerprinting feature is enabled, configured on the CLI as a filter in the DLP sensor, which allows you to choose the sensitivity level. After you have configured a filter in your DLP sensor on the CLI by setting Set Filter by Fingerprint, the File Fingerprint drop-down list appears on the GUI. In the File Fingerprint drop-down list, you can select one of the default sensitivity levels, critical, private, warning, or your own custom group of fingerprints according to their sensitivity level tag. DLP will scan and inspect these rules, filters for fingerprint matching from top to bottom. Because DLP stores the file checksum in chunks, it detects that the fingerprint file is changed from the original file and takes action as defined in the DLP sensor. The Diagnose Test application DLP Fingerprint CLI command provides many options to view statistics, dump all chunks, or refresh all document sources in all VDOMs. When configuring filters in the DLP sensor, continue to add filters until the sensor matches all traffic that it should, but doesn't match unintentionally. When you have added all of the necessary filters, apply the DLP sensor by selecting it in a firewall policy. The example on this slide shows a DLP sensor with a few filters. Each filter searches traffic for different types of sensitive information, such as a credit card number or fingerprint. If traffic matches a filter, FortiGate will apply that filter's action. Remember, DLP filters are evaluated for a match sequentially from top to bottom. FortiGate uses the first matching filter. For example, let's say an email contains a credit card number, which the sequence 1 filter says to block, but also has sensitive text, which the sequence 5 filter says to log but allow. FortiGate will use only the sequence 1 filter and the email is blocked, not allowed. Good job! You now understand DLP fingerprinting. Next, you will learn about DLP archiving. After completing this section, you should be able to enable DLP archiving, implement summary archiving, implement full archiving. By demonstrating competence in knowing how to configure DLP archiving, you will be able to use the archiving feature to support short-term forensic investigations. Until now, you've seen DLP blocking or monitoring sensitive data. But what else can DLP do? It can record traffic summaries, that is, logs, and if enabled, the full files and messages that were contained in the traffic. If you are familiar with content archiving in older versions of FortiOS, you will recognize summary archives and full archives here. Summary archiving records a log message that summarizes the traffic and therefore varies by protocol. For example, for an email message, the summary archive would contain the sender's email address, the recipient's email address, and the size. When users access the internet, FortiGate logs record every URL they visit. Full archiving records the summary log, but a complete email message, including any attachments, is also archived. When a user accesses the internet, every page the user visits is archived. This can be useful in forensic investigations. However, it's not meant for prolonged use. Depending on what you're archiving, full archiving can require large amounts of FortiGate's disk, CPU, and RAM resources, which decreases performance. For example, if you fully DLP archive a 100 megabyte file, FortiGate will store more than just 100 megabytes. It stores the data plus Ethernet, IP, and other headers that were used during network transmission, plus the log message. So it requires slightly more than 100 megabytes of storage. It also requires RAM and CPU until FortiGate finishes writing the file to its hard disk. Full DLP archiving also consumes disk space that FortiGate may need for other UTM features. So, for performance reasons, it's better to use FortiAnalyzer or an external storage device. If you need to inspect and archive email, especially for prolonged times, then FortiMail may be a better alternative. It has local archiving plus anti-spam, secure messaging, and other in-depth features that FortiGate's SMTP proxy cannot support. Good job! You now understand DLP archiving. Next, you'll learn about DLP best practices. After this section, you should be able to define best practices for implementing DLP, use best practices to avoid implementation issues, common problems, and network impacts. By demonstrating competence in DLP-specific best practices in troubleshooting, you will be able to identify, prevent, and resolve most of the common DLP-related issues. This slide shows a list of suggested best practices. When implementing DLP, you need to take several things into account in order to prevent issues. Remember that DLP filters are applied in the order listed. Ensure that your most precise filter is listed first, with the more catch-all filters listed last. You should also ensure that any file name-based filters are correctly applied to accomplish the desired task. Archiving and logging are also recommended for post-incident forensics and to achieve PCI DSS compliance. You also need to create appropriate filters between internal teams in order to ensure there are no inadvertent leaks through internal sources. Also, make sure that all filters are correctly replicated to redundant firewall policies to ensure business continuity. It is also a best practice to use learning profiles to simplify the creation of DLP filters and ensure that no potential leaks are missed. Congratulations, you have completed this lesson. Now you will review the objectives that you covered in the lesson. This lesson covered the following objectives: define the purpose and function of DLP, differentiate filter types for files from filter types for messages, configure DLP filters for files and for messages, configure DLP fingerprinting, enable DLP archiving, implement summary archiving, implement full archiving, define best practices for implementing DLP, use best practices to avoid implementation issues, common problems, and network impacts.